Okay, here's another try at those questions from 6-5 that I posted a video for, but we might need a little bit more clarification. So I'll just do a couple of those just to see and show you why it is that we might get two triangles or no triangles at all. So this is 6-5, just continued. Um, so first off, this is only when you have this situation that comes up. So if we have a triangle like this, and let's just say this angle here is angle A, and A has to be an acute angle for this to work out the way this is going, and we know side B and we know side A, and one thing, I mean it could be C's or B's or whatever, but we know an opposite pair and we know the side that came in between that angle and that side. And this is just special if B is bigger than A. So some things that have to be true is angle A has to be acute, or this doesn't matter, and then B has got to be greater than A. So there are occasional times, or sometimes, that you don't know that the triangle is going to look like this. It could be an acute angle like this one that I've drawn, or it could be an obtuse one that would be drawn like this. The A would be switched over to that side and it would still be the same distance, because the only thing for certain that we know is this angle that we've made, this length and that length. So it could swing back and forth. It could either be on the outside and make it an acute triangle, or it could swing that way and it could be an obtuse triangle. Obviously mine is not drawn to scale. Like I can't draw things to scale, y'all know that. So I'm just going to show you a situation and then how we can figure out when it is that we're going to use two separate triangles, or have to do two separate triangles. So let's say that B is 12, little a is 10, and angle A is 25 degrees. So I'm going to go ahead and draw that, but we do know that the side that's in between these two is bigger than the other side, and it's an acute angle, so we have a chance that we're going to have to make two triangles out of this situation. So I'll go ahead and sketch what I think it's going to look like. Might have to change it. Ooh, that looks pretty bad. So we have 25 degrees, 25 degrees in here, 12 there, and 10 at this point. So what we have to do is we're going to figure out if we're going to get two triangles out of this, or we're going to get one triangle, or we're not going to get any triangles at all. So the first thing that I would do in this particular problem is I would go ahead and see if I could find this other angle just by using law of sines. So I'm just going to try to do law of sines first. So that's sine of 25 degrees over 10 equals sine of, I'm going to label this B, B over 12. Remember this from the other day. So 12 sine of 25 degrees is equal to 10 sine B. So we'll divide by 10. I'm going to go ahead and type this into the calculator right now. I should have done it beforehand, but bygones. Oh well. 12 sine of 25 divided by 10 is 0.507, yada yada yada. Let's do the inverse of that. So inverse sine, what we just got, 0.507. So inverse sine. And it looks like angle B should be around 30.47 degrees. So right off the bat, we know that the triangle exists. Sometimes when you do problems like this, you get an error at the end, and then you know that no triangle would be able to be made in this situation. That would be like if instead of giving us 10, they gave us like 4 in this section. They said, oh, this is 4. But there's no way that 25 degrees, when that draws all the way out, you wouldn't hit the 4, because that's stuck right there. So we need to know, we would just know that if it didn't make it when you do it in the calculator, it's not going to make it. You'd have no triangles at all. So that's your first test. I always test that first. And now I'm going to see, so I know for sure I have one. Now I'm going to test and see if I could have another one. So if I had another triangle, remember it would, this 10, instead of being this way, it's going to be in the opposite direction. Okay? So there would be a 10 there, and so our triangle instead looks like this. It's like a little teeny tiny wedge, where this is 12 and this is 10, and we still have that 25 degrees in there. Okay. So if we're for certain that this is going to make a triangle, that will be good. It's really easy to figure out what this angle is, just because of what we know about isosceles triangles. But first I'm going to see if we actually do have two triangles. And for us to do that, we need to know what the height is of our original triangle. So if I check this out, if this 10 is shorter than that, when this swings, it's not going to hit the line underneath. It's not going to work out for us. So that's how we would know we're not going to get a triangle. So we're just going to test and see. You could also check this way and test and see. I would do that probably rather than doing this, but that's okay. It doesn't really matter. So this is another test to see if you're going to have that secondary triangle, because it needs to be longer than your height. So I have a right triangle, sine of 25 is equal to h over 12. If you multiply by 12 and see what that is, 12 sine of 25, we will see that 12 sine of 25 is 5.07. So with this height is 5.07, so obviously 10 is longer than that, so it's going to hit it the 2 times. It's going to swing back and forth. So just an aside, you don't have to do this. If you just run through it that way and actually get a number, it's going to work out and you'll be fine. So you don't have to do this test that I just did for the height. But if you want to, that's okay as well. Alright, so now we know that angle B, when we draw the triangle this way, is 30.47. Since this little one on the inside is isosceles, then also this is 30.47, which is the angle that's right outside of the one that we're looking for here. So we can just subtract from 180 to get the obtuse angle that we'd be missing in our secondary triangle. So 180 minus 30.47, and that's going to give us our second angle, which is 149.53. So if you were to try and solve both of these triangles, when you're solving them now, you would use, you would subtract and then use law of sines with the remaining angles that you have here. Okay, so that was kind of confusing because I was going through all of the stuff, so I'll just do one more and just show you that once you know what to do, it's just all pretty quick. Okay, so I'm going to do another one. I'll pick some numbers. Let's go with, I'll just draw the triangle, I don't care. Let's say that this is 32 degrees, this is 13, and this is something smaller than 13, but not that small. Let's go with 9. Okay, so the first thing I'm going to do, I'm just going to check. I know that the number in between them is bigger. I know this is an acute angle. I'm going to do law of sines, see if it works out. And if it does work out, then I can draw my 9 this way as well and figure out everything that happens. So here we go, law of sines. Sine 32 degrees over 9 equals, what are we trying to find? This angle here? Okay. Sine of x over 13. A 13 sine of 32 equals 9 sine of x. Divide by 9. So 13 sine of 32 divided by 9. Do the inverse sine. And I got that x was 49.95 degrees. So I know that it's going to work out with this triangle. So now I can draw both of the triangles that I know and then find anything else I need to. So here it is, the regular acute one, and I need to also take into account that this can go back this way. So these are both 9 and 9. So I'll draw my other triangle. Ooh, this looks horrible. I'm not an artist. Okay. So this was 9, 13, skinny 10, 9, 13, 32, and also 49.5. Okay. And 9, 13, 32, and this is not 49.5. The exterior one is 49.5. So for us to find this interior one, you say 180 minus 49. Oh, not 5, 95. 95. And this is 130.05. So you can go through, solve the rest of the triangle, subtract from 180, use law of sines, subtract from 180, use law of sines to find the remaining ones. Okay, hopefully that made any sense at all. I don't know. I think this example was better than the first one. So remember, you don't have to do the thing about the height if you don't want to. You can just check and see if it exists in the first place. That's probably what I would do, because the calculator is going to let you know right off the bat if you don't have any triangles at all for that situation. Okay? All right. Well, happy mathing. That was pretty cheesy, but y'all have a good rest of the day.